Alexa, white lamp on.
Okay.
Alexa, white lamp off.
Okay.
Alexa, green lamp on.
Okay.
Alexa, green lamp off.
Okay.
Alexa, lamps on.
Okay.
Alexa, lamps off.
Okay.
Hi and welcome to Bytes and Bits. If you use Alexa for your home automation, you'll know that it's a great system allowing you sort of hand-free control for a range of smart devices and access to information and so on. Now, wouldn't it be great if we could actually use Alexa and its skills to connect up to our microcontrollers, such as this ESP32? So in that way, we could actually use voice commands through Alexa, being fed out to our projects to actually control those in some meaningful manner. And that's what this tutorial is going to start us on the way towards. So in this tutorial, I'm going to be looking at how we can use a ready-made Alexa package, customized for the ESP32, but will also be suitable for the Raspberry Pi Pico W. And that will allow, well, in effect, it turns our ESP32 into a Philips Hue bulb. And that is a protocol which has already been designed and added as an Alexa skill that we can then hook into. And that will allow us to send commands using our voice over Alexa to our microcontroller board. And it will then receive commands which will have an on-off state, a device ID, and then a brightness value. So in effect, we're going to get 2 bits of data coming across into here. So we will select the device. It will then give us an on-off and a numerical value. And we can then use that to do whatever we want on that side of on our project. So as I say, the package we're going to use today is something called FauxmoESP. And I say that is ready-made, but it will show us the basic principles of how we can use Alexa to connect to our microcontrollers. And then in subsequent videos, I'm going to be taking that step further, where we will start to create our own Alexa devices and our own Alexa skills to customize that process that much more. But let's get started then and see if we can get this device here, this ESP32, hooked up and controlled by Alexa. So first of all, we're going to need to get hold of some of the libraries for this project. So again, if you head across to the FauxmoESP website and you get to this GitHub repository, and again, I'll put links to this down in the description. So this is the main project page for this library. As you can see there, it just tells you what it does there. And we have, of course, versions within this system then for the ESP8266, the ESP32, which we're going to be using, and of course the Raspberry Pi Pico W. So if you scroll down here, you'll see some information about the project itself. Really what we want to come down to is this dependencies section. So these are the libraries that we need to have in our Arduino IDE so that we can actually compile and then run this software. So you can see here, depending on which particular processing board you're going to use, you're going to need that version of this asynchronous TCP server. And that's basically going to provide us with in effect, a web interface so that the Alexa devices can connect to our microprocessor board or our ESP32 and then send and receive messages from it. So for our ESP32, we're going to need this async TCP library. Now, the really good thing, of course, about the Arduino IDE is that a lot of this library functionality is built into the system. So we don't actually need to download and install anything manually here. We're going to go across into our Arduino IDE and get everything set up in there. So let's jump across and do that. So in our Arduino IDE, if we go across to our library manager, and then the first one we're going to have a look for is this async TCP library. So that should pop up for you. So again, you can see I've obviously been playing around with this project, so I've already installed mine, but you simply then want to install that library. Once you've done that, then of course we just want our FauxmoESP library. And again, you want to install the latest version of that one. So once we've got our libraries installed, we should then be able to pull up the example files from our Arduino IDE. So if you go up to the File menu and Examples, and then we're going to have to scroll down for our, let me just pull that in screen for you, and a bit more. So our FauxmoESP, you can see there we have this basic example. So if we pull that up, and we should then see the code for this example. So we need to make some modifications to this code and to rename this credentials file. So first of all, we need to save this then as a new sketch inside our sketches folder. So if we go to File and Save As, inside our sketches folder then, really just going to put this somewhere sensible. So I have an Alexa ESP32 folder, and I'm just going to call this particular one tutorial, because this lets me know that this is the one I'm using in this tutorial. So let's just save that. So we should now have our new sketch saved outside of our example system, and we can now go off and modify this. So the way this works then is that this credentials.h file is basically going to be this file renamed, but with our Wi-Fi network and password details in here. Now we can't change that out inside our Arduino IDE, so we're going to need to go into our File Explorer. So if I bring up my File Explorer and just refresh that, I have now my tutorial sketch in there. So if I come in here, and all I want to do is I want to rename this credentials file to credentials.h. If I do that, and there we go. Okay, so if I come back into my Arduino IDE, so you should see now we have our tutorial sketch file here, and then our credentials header file here. So all I need to do now is in the Wi-Fi SSID, I need to put my network, my Wi-Fi network SSID value in there, and then of course my Wi-Fi password into this. So just type it in between the inverted commas. So once we've got those credentials entered and that file saved, we really are ready to do some testing. So the example program is designed to run a few LEDs off some I/O pins, but we're not going to bother with that just yet. We're just going to make sure we get everything working. So the way this code works then is we, of course, have a number of sort of setup functions here. So one, of course, is turning on the Wi-Fi network and connecting that up then in what's known as station mode, and that will allow our Alexa device to connect to us over our Wi-Fi connection. We then, of course, are setting up a little bit on the I/O side of things. And then, of course, we're coming down here and creating our FOMO server. So this is going to be the actual server. So it's going to listen through our async TCP server. So our messages are going to come in from Alexa through our async TCP. We're going to pick those up then in our FOMO server. And then we're going to start decoding those. And basically what's going to happen is that as an Alexa command comes in, it will be received, and we will call a callback function here that is going to then, in effect, it's going to have a look and decode the values in that Alexa command. So we're going to get a device ID, which is going to identify which particular device we're talking to with Alexa. This particular Philips Light device, it has then the device ID, it then has an on or off state, and then a value coming in which is supposed to represent the brightness of the LED, or the lamp, sorry. And that's what we're going to be sort of hooking into in a little bit. So really all that's doing here is, this is the line in particular here that we're looking at the moment, which is really just going to say when a command comes in, just print it out on our serial terminal so that we can see what Alexa is trying to do. After that, it's going to go down here and start playing with the LEDs themselves, but we're going to come to that in a wee bit. So we do have enough now to test this out, get it connected up to Alexa, and see if it's actually working. So of course we need to now connect up our ESP32. So I'm going to plug in my ESP32 device, and I'm using one of the little dev kits for this. So I don't need to have it connected up to anything other than the USB port on my PC. So that's plugged in at the moment. I now need to make sure that I've got my Arduino IDE connected to it. So I'm going to go up to my Tools menu. I'm going to go to my board, Again, I've already got my board selected, but you would come in here into your board, you go up to your ESP32, and then find the ESP32 kit that matches up with the board that you're using. As I said, I'm using this ESP32 dev kit. And again, some of these are sort of common between boards. But just try and make sure you get the one that matches up with yours. We will then, of course, need to make sure that we connect it up to the correct COM port so that our PC knows how to talk to our board. And again, mine is going to be connected up to COM10. So we now have our sketch all ready to go. We have our board connected and connected to our port. So we need to put it into download mode. So I'm just going to turn on my serial terminal here, or my serial monitor. So again, I'm going to hold down, so my ESP32 is plugged into my PC and powered on. I'm going to hold down the boot button and then press and release the reset button. And you can see that has then put it into download mode. And I can then download my sketch from here. So once that's compiled and uploaded to our ESP32, we should now have an Alexa device sitting on our network. And you can see here that we have every 5 seconds it's running this little down here in this loop. So it's running through, it's handling any responses from Alexa or looking for some responses, and then it's running this little loop here where it's going to print out this message every 5 seconds to do with the heap and memory leaks and so on. So again, that just lets us know that everything is running. Now what this sketch does is it actually creates, if we look up here, where are we? Okay, so in our FauxmoESP setup, we can see here we are adding 5 devices. So these are going to appear as 5 separate lamps to Alexa. So this one single ESP32.
I don't know that one.
Yeah, and I obviously said Alexa there, and she's hooking in with that. So just ignore her in the background. But what's happening then is we have this ESP32 is able to set up multiple lamps for us to use. So you can see here we are adding devices in. So we're going to create what it's calling here yellow lamp, green lamp, blue lamp, pink lamp, and white lamp. But we're just going to connect them to LEDs in the end. So if we now come into our Alexa app, so I'm just putting up my phone screen over here, and then we can see the serial output from our ESP32. So if I come into my devices section, and then if I go up and add a device, so we're going to add some devices. And we want to come down here to some other devices. And we're going to connect them via Wi-Fi. And we're going to go and discover devices. So at the moment, Alexa is now scanning our Wi-Fi network, looking for any devices that will respond in the correct format to be an Alexa device. So you can see that it has found 5 devices, and these should of course be our 5 lamps. And there we have them. So again, in our code over here, you can see that when we added the device, it used these ID values, and these ID values are defined somewhere up here. So again, you can see here our ID yellow is yellow lamp. So those are the words that we will use to reference this particular device when we use Alexa. So if I come back into my visor screen, which is somewhere over here, and there we go. Okay, so again, Alexa's just piping up in the background there again. Every time I say the word Alexa, she kicks in. So we now have these devices. So these devices have now been discovered on our network, and they have now been connected up to our system. So if we come back then out of here, we should find in our devices section, we should now find we have these devices. And of course, at the moment, they're unresponsive because we haven't yet used them as such. But I can come in here and I can call up my blue lamp. And you can see at the moment, it's sitting there with its power off. So by default in our system here, if we come down, you can see that when we define our LEDs, we set them to all be off. Okay. So if I come in here, what will happen is if I click the power on, it will send a network command to our ESP32. That network command will contain a device ID, which will be our yellow lamp, or in this case, blue lamp. Its state will then go, of course, it will say it'll be on, and then it will then give it a value, which is this brightness value. Again, if we just turn it on, it will actually go to full brightness. What we should find then is that message should appear in our serial terminal. So if we come in here and say on, you can see that we now have our device number 2. So again, it's given its code number. This is being decoded then by our example code to be the blue lamp. It's turned it on with a brightness value of 255, which is full on. And you can see that sitting here. So I can, of course, then change the brightness on this down to about 40%. And you can see there that we now have device 2, the blue lamp, has been set to 107. So again, we're going from 0 to 255 being 0% to 100%. So just below 50% is that. There is a color, of course, put out here for the Philips device. That's not implemented in this particular example code, just the on-off state. So again, I can turn it off. So you can see there we have turned it off. So just the on-off state and the brightness state. So we now can see that our Alexa device is working. So let's just see if it will actually do it then via the voice commands. Alexa, yellow lamp on.
Okay.
And there you can see that Alexa has heard what I've just asked it to do and has put in the yellow lamp and turned it on to a brightness value of 255, which is fully on. We can, of course, then set that to half brightness. Alexa, yellow lamp 50.
Okay.
And there we see that it has responded back and put our yellow lamp to exactly 50% brightness. So everything is working here. And you can see very quickly we now have our ESP32 able to create these Alexa devices. Okay, so the FauxmoESP package does create devices which simulate the Philips Hue lights. And that, of course, will then give us the idea of being able to turn an output on or off. And then we can associate a value with that output and how we interpret those numbers coming across. So as you can see in our code, they just arrive as what device we are talking to, whether we want it on or off, and what value we want to attach to that device. How we then interpret that is up to us. So let's do a little bit of code to actually make that do something sensible and play about with our Alexa lamps. So this sketch is a modified version of that example sketch, and you can see I've just called it ESP flashing. And again, I'll put the code for this as a GitHub repository which you can download, and there'll be a link for that in the description down below or on the project page on my main bytesandbits.co.uk website. So the code itself is pretty much the same as before. So again, you can see we're using that credentials file to get the Wi-Fi set up. We do need to make sure that we define the GPIO pins for our 5 outputs. And all I'm doing here is I'm using 5 GPIO pins. They're going to be driving LEDs. So I'm going to drive these high. So my LED will need to be connected between this pin through the LED down to ground. So there's 5 of those. Again, we're going to use the same names for them. So the yellow lamp, green lamp, and so on. I'm going to be using the value to control the rate of blinking of each of the LEDs. So again, remember, what I really want to get from this tutorial is that although we are using a library that simulates these Philips Hue lamps, really all we're going to be getting through on the ESP side is which device we are talking to, whether we want it on or off. And again, on or off could mean whatever you want it to mean. And of course, then a value which should be the brightness, but is really just a value between 0 and 255. So I'm going to use that as the rate of blinking of the LEDs rather than the brightness. So this block of code here is really just setting that up and allowing me to set up various timers for each of the individual LEDs. After that then, if we just go through the code in a bit more detail here, this is exactly as it is in the main example. So we of course have got our Wi-Fi setup function here. We then have our main setup function, which is going to start our serial terminal. It's then going to set up our digital I/O pins, set our Wi-Fi server going, then connect our FOMO server to that on port 80. Then we're going to add our 5 devices in. This is the main bit of code here, which is our interface with our Alexa. So we have this on set state. So that is a function that is called when a command is received. And that then uses this idea of a callback function here, which is being put in as this sort of and obviously Alexa's chiming in again. So this is sort of like a lambda function here, where we're defining just a basic function to handle that command coming in. And again, that's where it prints out the actual command that's being received. It then decodes that command, and all we're doing here is we are saving the values coming in. So I've created a couple of arrays which are going to hold the current state of the lamp, so whether it's being turned on or off by Alexa, the value of the brightness then for each individual lamp, and that's it, just putting those then into an array. Now this callback function here, really you don't, as it says up here exactly, you don't want to spend too much processing time in here. We really want to come in here, save the data that's been received, and then get out of it so we can then go back and then check for the next message coming in. So you can see here all we're doing is we're just storing the values into those arrays and then exiting out of the bottom of that loop, bottom of that function, sorry. So this was the main loop which actually does the work for us. So this FOMO.handle, as you can see it's saying here, we do need to manually pull the server to see if we have had any new commands coming in. And that's what that function there does. So that will do that. If there's a command coming in, it will be triggered. It will trigger this callback function, and that will then store the values for the lamps in those arrays. This little bit here is really just been put in by whoever wrote this example code, just to, in effect, show us that something is actually happening. And I think it detects memory leaks, but again, it's not such important. It's just letting us know that something's going on. After that, then we have the actual blinking timer that I've added in. So this bit here, it's using a 10 millisecond period. So each tick on the blinking counter is 10 milliseconds. So that's what this first line is doing here. After that, then it's really just using a set of counters. So each LED has got a current toggle state, which is whether it's actually on or off. It then has a little countdown timer, which gets reset to the value that we receive from the Alexa command. So that Alexa command from 0 to 255 for our 0 to 100% brightness, that turns into a number, and that then is the reset value for the counter. So if we receive a value of, say, 10, that's going to take 10 ticks off our toggle counter here before it then flips the value of our lamp. So in effect, a value of 10 will mean that every 100 milliseconds, our LED will change state from on to off, or vice versa. So again, that toggling and that blinking only happens if our lamp state is set to on. If our lamp state is set to off, then it just stays off all the time. And that's repeated across then all 5 lamps. And that's all that this one is doing. So let's boot that up and see if we can use Alexa to talk to these lamps and control the blinking rates. The circuit we have here then is basically our ESP32 with our 5 LEDs connected to these 5 I/O pins, feeding down to a common 0 volts here. I've marked W, P, B, G, and Y for our white down to yellow LEDs, and they relate then across. Obviously, I've only got red LEDs in here. And then we have, of course, our Alexa Echo device. So everything is connected up. So let's just make sure that everything is going. So we have our yellow LED here. So I can, of course, turn that on. And if I give a brightness value, that will then control the rate at which it blinks. So if I try and get it to blink fast by giving it a small number, Alexa, yellow lamp on 10.
Okay.
And there we have it blinking now at a sort of a fairly fast rate. I can of course get it to blink at a faster rate. So if I use the green LED then, Alexa, green lamp on 1.
Okay.
So there we have it blinking at the fastest rate. And again, we can carry on up these lamps here. So Alexa, blue lamp on 50.
Okay.
And there we can see it now at a slow rate, and so on. So we can see here that we are now getting our Alexa command coming out through our system into our ESP32, being decoded then both in terms of which device we are talking to, whether it's on or off, and then of course this value, and of course we're using the value here to control this blink rate. Once we've got the system in like this, of course we can then start to use all the other features inside Alexa. So we can I've grouped these all together as a device group called lamps. Alexa, lamps off.
Okay.
And we can turn everything off in one go. We can of course then control them all together. Alexa, lamps on 20.
Okay.
And you can see we now have them all blinking at that sort of medium speed, but controlling them all in one go through the Alexa app. So that's really our Alexa using our ESP32 all set up. So again, this FauxmoESP library just lets us do...
I'm not sure.
Let's just see if we can turn her off a bit. So you can see here that this FauxmoESP library then lets us very, very quickly get our ESP32 able to talk to Alexa so that we can actually send some commands through to her and get them coming out on here. And again, how we interpret those commands as to what actions we take with them, that is entirely up to us. So the next step then is we are using a package which emulates or pretends to be one of these Philips Hue bulbs. So again, Philips then obviously developed their own Alexa skill and connected that up into the Alexa system so that we can then drive their bulbs. So the next step, of course, is to see if we can actually create our own Alexa device with our own Alexa skills and then get it to actually control our hardware in a meaningful way. So we'll have to learn how to create our own language and get that inside Alexa so that it can respond to our commands, get those commands out to our ESP32, which can then decode them and then take the appropriate hardware actions to make that action take effect. But we're going to do that in another video. So if you want to have a look at that, and if you've enjoyed this one, please do like and subscribe to the channel for more of these making, coding, and of course retro gaming videos as well. I look forward to seeing you again in another video very soon, and bye for now. For more games programming, electronics projects, and retro gaming, please make sure you like this video, subscribe to my YouTube channel, and visit my website.